Hello, everyone. Welcome. My name is Niles, and today I'll be covering my recent article, CosmWasm, Pushing the Boundaries of Smart Contract Innovation. So without further ado, let's dive right in. Innovation in smart contract development continues to be a driving force behind the transformation of various industries. One particular framework that has gained significant attention is CosmWasm. In this article, we explore what CosmWasm is and how it has emerged as a leading-edge solution in the realm of smart contract development. Additionally, we delve into the analysis of key data points to understand the adoption, usage, and growth of CosmWasm, shedding light on its impact on Web3 innovation. Also note that while I'm not a developer and wouldn't personally consider myself an expert on smart contracts, I've done my best to explain the concepts and functionality of CosmWasm as I understand them, and to draw meaningful conclusions and insights from the data I've collected. This article has no official affiliation with CosmWasm. So CosmWasm is a smart contract platform focusing on security, performance, and interoperability. As an open source framework that enables the execution of secure and efficient smart contracts, it was developed with modularity, reliability, and compatibility in mind. In short, CosmWasm offers developers a flexible environment to build and deploy smart contracts with ease. By combining a modular design, WASM compatibility, IBC protocol integration, cross-chain transactions, and support for chain-specific features, CosmWasm empowers developers to build multi-chain smart contracts that can interact seamlessly with various blockchains within the Cosmos network. This capability opens up opportunities for cross-chain applications, interoperability, and the creation of complex decentralized systems spanning multiple chains. CosmWasm directly integrates with the Cosmos SDK, a popular framework for building blockchain applications. By choosing CosmWasm, developers unlock the potential to build innovative solutions while integrating seamlessly into the Cosmos SDK and leveraging a native union with IBC, the Interblockchain Communication Protocol. This integration leverages the existing infrastructure and optimizes the Cosmos ecosystem, further enhancing the efficiency of CosmWasm-based smart contracts. Thus, CosmWasm enhances the possibilities for collaboration, providing tools for an ecosystem of interconnected blockchains to grow exponentially. By leveraging the Rust programming language, CosmWasm provides a robust and secure execution environment, making it an attractive choice for blockchain developers seeking to create decentralized applications and smart contracts. While CosmWasm primarily uses Rust, compatibility extends beyond Rust, accommodating other languages compatible with WebAssembly such as AssemblyScript, C, and C++. This compatibility allows developers to leverage existing code bases, streamlining integration and expanding possibilities. Additionally, CosmWasm's architecture prevents many known risk vectors encountered in traditional smart contracting platforms, such as the Ethereum virtual machine. The adoption, usage, and growth of CosmWasm. Launched in 2019, CosmWasm has emerged as a leader among the available frameworks for smart contract development. To gauge the impact and growth of CosmWasm, we conducted a data analysis examining key metrics over time. The analysis included the number of blockchains utilizing CosmWasm, the number of forks of the code on GitHub, and the number of developers contributing to the framework. So chart number 1 illustrates the steady rise in the number of blockchains adopting CosmWasm as their smart contract execution environment. This chart shows a steady rise in the number of projects utilizing the framework. Chart number 2 highlights the developer community around CosmWasm, showcasing the increasing number of forks of the framework's code on GitHub. The growing interest and contributions from developers demonstrate the collaborative nature and open source ethos of CosmWasm. Chart number 3 showcases the code frequency and presents the number of additions and deletions made to the CosmWasm codebase over time. While it's not the only factor to consider, consistent additions and deletions in the codebase indicate active development. Chart number 4, the contributions graph on the CosmWasm's GitHub repository provides a visual representation of the frequency and intensity of contributions made by individuals and the community over time. By observing the contributions graph, one can assess the project's overall development momentum and involvement from contributors and identify periods of heightened activity or potential gaps. It can serve as a tool to understand the vibrancy and productivity of CosmWasm community and their commitment to CosmWasm's advancements. Technical details highlighting CosmWasm's security advantages. CosmWasm, as a smart contract platform, incorporates its security model and design principles to offer advantages in security, including increased securitization against reentrancy attacks when compared to the EVM. While CosmWasm does not rely on specific mechanisms like mutexes or external call checks for reentrancy prevention, its security model and design choices lay a strong foundation for secure contract execution. It is important for developers to be aware of the risks associated with reentrancy attacks and to implement proper contract design to mitigate risks effectively. The following are several characteristics of CosmWasm that offer security advantages when compared to other virtual machines, such as the EVM. Memory safety. By leveraging the Rust language, CosmWasm inherits strong memory safety guarantees. Rust-specific compile time checks prevent common memory-related vulnerabilities like buffer overflows, null pointer differences, and data races. This ensures that smart contracts written in Rust and executed on CosmWasm are less prone to security exploits caused by memory vulnerabilities. In contrast, the EVM, being a more mature platform, relies primarily on the Solidity programming language for writing smart contracts. While Solidity has its own secure features and practices, it does not offer the same level of memory safety guarantees as Rust. Solidity's design choices and language features can potentially introduce memory vulnerabilities if not carefully handled by developers. Sandbox environment. CosmWasm's security model takes an isolated approach to smart contract execution, ensuring that each contract operates within its own dedicated WebAssembly WASM virtual machine sandbox. This means that the behavior and execution of one contract are simply and completely independent of others, providing a higher level of security and reliability for the entire smart contract ecosystem. The security actor model in CosmWasm further enhances the isolation and security of smart contracts. Inspired by the well-known actor model in concurrent computation, each smart contract is treated as an isolated actor within its own encapsulated state and behavior. These actors interact with each other through well-defined messaging passing, enabling secure and controlled communication while preventing direct interference between contracts. This design principle significantly minimizes the risk of unintended interactions or malicious activities between contracts. It ensures that the actions and state of one contract cannot directly affect or modify another contract, preventing scenarios where one contract gains unauthorized access to sensitive data or funds of another contract. The security actor model not only enhances security, but also improves scalability and performance. Since each contract operates independently within its own sandbox, they can be executed concurrently, taking advantage of parallel processing capabilities. This concurrently leads to increased efficiency and throughput, enabling the blockchain to handle higher volumes of transactions. In contrast, the EVM's approach to contract execution within the Ethereum network lacks complete sandboxing at a contract level. While there are mechanisms such as consensus protocols and gas limits to provide some level of isolation, vulnerabilities in one contract can potentially impact other contracts within the shared network. This poses a higher security risk and limits the scalability and performance potential compared to CosmWasm's isolated execution model. Formalized governance. CosmWasm also incorporates formalized governance processes that allow the community to propose, discuss, and vote on changes to the protocol in the execution environment. This decentralized governance ensures that security-related enhancements, bug fixes, and upgrades can be implemented swiftly and transparently. With a formalized governance structure that can also leverage the existing governance infrastructure of the underlying blockchain, CosmWasm promotes collective security-conscious efforts and maintains a strong focus on addressing any emergent security concerns promptly. In contrast with the EVM, itself does not inherently utilize formalized governance mechanisms. However, Ethereum as a platform has introduced various governance mechanisms such as the Ethereum Improvement Proposal, EIP, process, and on-chain voting to make decisions about protocol upgrades and changes. A battle-tested framework. CosmWasm benefits from the extensive real-world usage and testing within the Cosmos ecosystem. The framework has undergone security audits, code reviews, and penetration testing by both internal and external security experts. Here, linked in the article, you can find Oak Security's recent CosmWasm audit report. This approach ensures that CosmWasm continues to be thoroughly scrutinized for vulnerabilities and evolves to become a mature and secure smart contract platform. Given these strengths in regard to security, CosmWasm is growing as a secure and efficient solution for executing smart contracts on public blockchains. Its focus on memory safety, formal verification, sandboxing, formalized decentralized governance, and extensive testing provides developers and users with greater confidence in the security of their smart contract deployments. When comparing CosmWasm to the Ethereum virtual machine, CosmWasm also demonstrates superior efficiency in terms of execution speed and resource utilization. Technical details highlighting CosmWasm's efficiency advantages. Compiled execution. CosmWasm smart contracts are compiled ahead of time into WebAssembly WASM bytecode, which offers significant performance benefits. Unlike the EVM, which relies on just-in-time compilation, CosmWasm's compiled execution eliminates the need for interpretation and allows for more efficient and faster contract execution. Lightweight resource footprint. CosmWasm optimizes resource storage by employing a minimalistic design and a lean execution environment. The compiled WASM bytecode is designed to be compact and efficient, resulting in smaller contract sizes and reduced memory footprint during execution. This efficiency ensures that blockchain nodes can process more transactions in less time with lower resource requirements. Gas model flexibility. CosmWasm introduces a gas model that provides greater flexibility and control over the cost of executing smart contracts. Gas is a measure of computational effort required to execute a contract, and CosmWasm allows developers to define their own gas costs for contract operations. This flexibility enables developers to fine-tune gas costs based on specific contract logic and optimizes resource allocation, resulting in more efficient and cost-effective contract execution. The EVM operates on a gas-based model where each computational step incurs a certain amount of gas cost. This mechanism is in place to ensure the security and economic viability of the Ethereum network. However, it can sometimes lead to complex optimization challenges for developers and may result in less predictable execution times and increased costs when compared to CosmWasm. Execution environment modularity. CosmWasm's modular architecture allows developers to choose and include only the necessary components for their specific use case, reducing unnecessary overhead and improving efficiency. This flexibility ensures that contracts can be tailored to specific requirements without carrying unnecessary computational burdens, resulting in a more streamlined and efficient execution. Portability. CosmWasm is designed with portability in mind, making it possible to deploy and execute smart contracts on various blockchains, including those beyond the Cosmos ecosystem. This portability is achieved through the modularity and compatibility of the CosmWasm framework. Because the architecture of CosmWasm is built upon WebAssembly, CosmWasm smart contracts can be compiled into WASM bytecode, which can be executed by different blockchain platforms that support WASM. For example, Polkadot, a multi-chain network that facilitates interoperability between blockchains, has the capability to integrate and support the execution of CosmWasm smart contracts. By leveraging the WASM compatibility provided by Polkadot, developers can deploy and interact with CosmWasm contracts within the Polkadot ecosystem. The portability of CosmWasm offers several advantages. Firstly, it allows developers to write smart contracts using the familiar CosmWasm framework and tooling, reducing the learning curve while deploying contracts on different blockchains. It also enables code reuse and interoperability between blockchains, as developers can potentially deploy the same compatible smart contract across multiple platforms, increasing efficiency and reducing development efforts. Overall, the portability of CosmWasm opens up opportunities for cross-chain collaboration, allowing developers to leverage their existing knowledge and code base to build decentralized applications that can seamlessly interact with various blockchain networks, including Polkadot. The level of integration and support for CosmWasm may vary across different blockchain platforms, and the active collaboration and development efforts are needed to ensure seamless portability. Additionally, the decision to support CosmWasm on a particular blockchain lies within the respective blockchain's development community and their adoption of WASM as an execution environment. No solution is perfect. While CosmWasm offers many advantages, it is important to acknowledge that no solution is perfect and unforeseen vulnerabilities may arise, necessitating ongoing improvements. For instance, in a recent discussion featuring Jay Kwan, linked in the article, a limitation of CosmWasm was highlighted. WASM is a virtual machine originally designed for browser environments, not specifically for blockchains. Although there are experimental versions supporting languages like Go, their maintenance may be lacking. Additionally, CosmWasm lacks certain features available when compared to the No virtual machine. The No VM offers automatic persistence and mercantilization of memory after every transaction, providing unique capabilities for proving the state of applications. The choice of the smart contract language and its integration with the blockchain platform are crucial factors for a successful system. While CosmWasm has its merits, other systems like the No VM can offer more succinct expression of complex applications. In any case, it's important to envision a future where different smart contract platforms in various languages and even non-VM systems can interoperate to meet diverse needs. Here you can see details on CosmWasm's most recent vulnerability patch, and you can also read about CosmWasm's latest achievements here, including Sylvia, a new high-level framework to build CosmWasm contracts. So in conclusion, CosmWasm's emergence as a leading-edge solution in smart contract development highlights its ability to drive innovation and shape the future of decentralized applications. With its modular architecture, compatibility with the Cosmos ecosystem, and growing community of developers, CosmWasm has positioned itself as a powerful tool for blockchain projects. As we analyze the adoption, usage, and growth data, it becomes evident that CosmWasm is not only a promising framework, but a driving force in accelerating the widespread adoption of secure, efficient, and interoperable smart contracts. By pushing the boundaries of innovation, CosmWasm paves the way for transformative decentralized applications and serves as an essential catalyst for the broader blockchain ecosystem's progress. As developers continue to embrace CosmWasm and leverage its capabilities, I believe we can anticipate even more groundbreaking applications and use cases in the future, setting new standards for smart contract development and revolutionizing the way we interact with blockchain technology. And then below are listed further resources for CosmWasm and references in the article. Thank you so much for listening. The link to the article will be included in the description of this video. Wishing you a great day, and I will see you in the next video.